So welcome class to the final video of the series on qualitative analysis, complex ions, in particular the complexation of copper-2 with ammonia in water. So here we have a short video of when we first add aqueous ammonia to copper-2 nitrate. So here's a bottle of copper-2 nitrate. A light blue gel solution forms, which we're going to see when we add it. So I'm just going to speed along a bit. Oh, okay, so what we've done now, okay, so you've added about 2 drops of aqueous ammonia to copper-2 nitrate, and you get a light blue gel, which you can observe. Okay, so now what we're going to do is going to add more ammonia and see what happens to this light blue gel as we continue adding ammonia. Okay, so this is the next point of the video. So as you can see, the solution starts to turn a clear, dark blue. Once again, just like in the previous videos, to understand what happens at the molecular or ionic level, we need to know what is going on in the reactant solutions. So the question I'm going to think about as we watch the rest of the video is, how can a precipitate form and then dissolve back into the water? Okay, so you've got to think about where the copper-2 ions are. Okay, so aqueous copper-2 nitrate, as you can see here from this illustration, is a clear light blue liquid. Okay, so now we're going to look at what's happening at a molecular level. Okay, so let's fade out the water molecules, because there's quite a lot of them between the hydrated ions, so we can see the ions in the background. The hydrated copper-2 ions, here coloured yellow in the animation, occasionally collide with the negatively charged nitrate ions, but the water molecules keep them apart. Okay, now the reason why I've got rid of all the water molecules is this is really the only way dissolved species can be seen in the background. Okay, so as you increase the concentration, what you're going to do is you're going to get a lot more molecular crowding. Okay, so I just got rid of all the water molecules. Right, so let's look at what the building blocks of this solution are. Okay, so here we have the copper-2 ion. Okay, in terms of what it looks like. Okay, it's hydrated with 6 water molecules, and we also have the hydrated nitrate ion. Okay, so notice that for copper-2 plus, as we move on to the next animation, that the copper-2 nitrate solution, there are 2 nitrate ions for every copper ion. You can stop the video if you wish and count them. Okay, so the solution is always electrically neutral. Okay, the final solution shows that these ions are separated. So this is a useful example to illustrate that the total number of positive ions and negative ions are unequal, but the number of positive and negative charges are equal. Okay, so overall copper nitrate is a electrically neutral solution. So in summary, just starting this animation there, in the blue copper-2 nitrate solution, there are billions of hydrated ions with 2 nitrate ions for every copper ion. So another thing you can think about as you're watching this video is anhydrous copper-2 sulfate, CuSO4, is white, but CuSO4.5H2O, so when it's hydrated, is blue. So what do you think, what chemical species do you think is actually responsible for the blue colour? Is it the copper-2 plus? Okay, so we've had a look at the copper nitrate solution, so now let's look at the aqueous ammonia solution, which is slightly more complicated in its chemistry at the molecular level. Okay, so aqueous ammonia solution, as you can see here, is clear, it is colourless, and it is a liquid. Okay, so you can, playing this animation, you can see that occasionally an ammonia molecule pulls a hydrogen ion from a water molecule, forming an ammonium ion and a hydroxide ion. Elsewhere in solution, an ammonium ion collides with a hydroxide ion to reform an ammonia molecule and a water molecule. So there's actually two reactions going on inside the solution. Okay, so looking at the aqueous ammonia building blocks, there are actually four different molecules being involved. There is the ammonia molecule, there we go, which is the majority of the solution. Okay, so the aqueous ammonia is mainly ammonia molecules, with of course a large number of water molecules, which you're familiar with already. But due to the fact there's two reactions going on, there's a relatively small number of ammonium ions, which you can see there from the diagram and the animation, and also a small number of hydroxide ions, which you should be familiar with from your work with pH in previous years. Okay, so let's look at that in more detail. So at the symbolic level, the ammonia molecule pulls a hydrogen plus an ion from a water molecule, forming an NH4 plus ion, the ammonium ion, and a hydroxide minus ion. Okay, that's one reaction. In the reverse direction, okay, so there's two competing reactions, the ammonium plus ion donates a hydrogen plus an ion to a hydroxide minus ion to reform as a water molecule and an ammonia molecule, which you can see from the equation. So, in summary, even though these reactions are all occurring at the same rate, back and forth, there is always many more ammonia molecules and ammonium ions in than hydroxide ions in solution. Okay, so the next thing we have to look at is the complexing of the copper 2 plus with the ammonia. Okay, so this is the reason why we get this kind of first precipitate and then this dark blue, Prussian blue solution. Okay, so going back to the original complexation reaction, interestingly, a precipitate of copper 2 hydroxide forms first, which you see on the left, and as you add more ammonia, it dissolves to produce a dark blue solution. So what's happening? Well, hopefully this animation will help. Notice how the ammonia molecules replace water molecules around the copper ions to form new ions. This ion is called the tetraamine copper 2 ion. It's actually been complexed with the ammonia, as you can see there. Okay. So here it is with 4 ammonia molecules around the copper ion. In addition, 2 water molecules are loosely bonded to the copper in aqueous solution. Once these complex ions are formed, water molecules can replace the ammonia molecules to reverse the process. However, most of the copper 2 ions in solution are present as the amine complex. So finally, in summary, the precipitate and dark blue colour formed when aqueous ammonia is added to a solution is strong evidence for the presence of copper 2 plus ions. Okay, so final question to think about. Compare and contrast the copper 2 aqueous with the copper 2 NH342 plus ions in the complex. What is a complex ion anyway? Something to think about. So that's all it is. All the videos I'm going to show for qualitative analysis. So I want you to review these 3 videos when you're doing your internal so you can get an achieved.